I'm an academic, which means that I'm going to talk for about 25 minutes. So I'm going to make it easy. I'm going to make it easy on you, and I'm going to cut to the chase. 4 words. Think globally, act locally. All right. So when I get the hook, just remember those words, because I won't finish. It's just a joke. I'll be in time. Super wicked problems. As the moderator just said, we are in an age when we're dealing with environmental problems that are global. And those problems have been given the moniker of being super wicked problems. What's a super wicked problem? It's national to global in scale. There's no single point at which the problem originates from. It's originating from thousands, if not hundreds of thousands of different points simultaneously. The solutions are nuanced. They're not point of fact. It's not the kind of thing where 2 of us can sit outside at 5 o'clock and say, you know, this is the solution. It doesn't work that way. Much more nuanced. And the solutions that we could come up with potentially today, if the problem is not remediated, won't work tomorrow. And of course, you see the polar bear here. The poster child for this is global climate change, clearly. However, I'll talk about a couple of other areas where it's important as well. Now, in the face of that, what do we have to combat that? And as Matt said earlier on, you know, the engaged citizenry within urban environments, but also within rural environments. The engaged citizenry is actually the answer. So to tame super wicked problems, we need civilian participation, extraordinary mobility, being able to amass people to do work simultaneously in many different places at the same time, unconventional tools, and again, mobilization of large numbers of individuals. Okay, now you're all thinking, yeah, that's nice, that's Pollyanna, thanks a lot, buddy, next talk. Is this actually happening? Yeah, it's happening now. It's happening today. And I will give you 2 examples. And now I can relax a little bit because I know I'm getting towards the end of my talk, so I have some extra time because my 2-minute time frame hasn't even come up yet. But I'll give you 2 examples of that. The first is Chile. Chile is a coast. Chile is about 3,000 miles north-south and about 100 miles long. It's all surface area. It's no volume, right? Chile also is all coastal. So the coastal environment is their bread and butter, just like corn, soybean rotation and cattle in Nebraska is our bread and butter. Their coast is their bread and butter. In the middle of the Pacific Ocean, there is what's known as the Pacific Gyre that's carrying microplastics. What's the fate and transport of those microplastics? Students up and down the entire coast of Chile are generating data on microplastics that's winding up in peer-reviewed scientific literature and winding up being involved in Chilean regulation of their own marine environment. And it's being done by high school students in urban areas and also high school students in rural areas. Let me give you another example. This is the Mississippi River watershed. The Mississippi River watershed drains the Midwest. The Midwest is where a lot of agrochemicals are coming from. Those agrochemicals don't just affect us and our health, they affect the health of this entire watershed. So wouldn't it be great if we could look at the watershed all at one time and then look at the occurrence of these agrochemicals over time? We did that in 2014. And we actually looked at the occurrence of atrazine manning or arming citizen scientists with the proper tools. We allowed those individuals to go out and make measurements up and down the entire Mississippi River basin, from Lake Itasca, Minnesota, all the way down to New Orleans. The final point here is I was supposed to answer a question at the very end, and the question that you may all be having is, okay, that sounds kind of interesting. How could I do that in my hometown community? The answer to that is, come and talk to me. Thank you very much.